Welcome to today's Explainer. We're diving headfirst into the incredibly intense, high-stakes world of forensic ballistics. We often think of a crime scene as a room or a street, but today we're looking at how the human body itself acts as a canvas, literally recording the invisible, physical truths of a crime. Whenever a firearm goes off, it leaves behind a highly specific scientific signature. But what happens if someone tries to erase that signature? What do you do when the physical evidence seems to completely contradict the truth? In forensic medicine, the line between premeditated murder and justified self-defense often comes down to microscopic details that most people just wouldn't even know to look for. So, let's decode those details together.
To really grasp how powerful this science is, let's start with a gripping, real-world clinical case. We'll call it the washed evidence. Picture this. A young man is rushed into the ER with a single gunshot wound to his chest. It's absolute chaos. Alarms blaring, people rushing around. And an ER nurse, working frantically in good faith to save his life, heavily washes and scrubs the wound with betadine and alcohol before the forensic pathologist even gets there. Shortly after, a suspect is arrested. He's super confident, claiming he fired in self-defense from over 5 meters away. And honestly, looking at that scrubbed wound, his story kind of holds up. It looks like a completely clean hole, no soot, no smoke. By washing it, the nurse unknowingly destroyed critical evidence. So, here is our central puzzle. How did the pathologist still manage to scientifically prove the shot was actually fired from less than 60 centimeters away, completely obliterating the guy's 5-meter alibi?
All right, let's dive into this. Before we can solve that mystery, we need to build up our forensic toolkit, starting with the weapons themselves. Broadly speaking, firearms fall into two camps, rifled and smoothbore. Rifled weapons, think handguns, assault rifles, have barrels with internal spiral grooves. These grooves physically grip the bullet and force it to spin, kind of like a perfectly thrown football, which gives it pinpoint accuracy over long distances. Smoothbore weapons, like shotguns, are exactly what they sound like. The barrel is completely smooth inside. Instead of one spinning bullet, they fire a cluster of metal pellets that spread out as they fly. At close range, it's one devastating hole, but as you back up, those pellets spread into smaller satellite wounds.
Now, understanding the gun is only half the battle. We've got to look at the ammunition. Here's a key mechanism explained. A cartridge is way more than just a bullet. It's actually 4 components, and pulling the trigger sets off a violent, instantaneous chemical reaction. First, the primer at the base detonates. Second, that spark ignites the propellant, the gunpowder, which burns incredibly fast and creates a massive wave of high-pressure gas. Third, that explosive gas launches the projectile, the bullet, out of the barrel. And fourth, the empty case is left behind. Why is this anatomy so crucial? Because it tells us exactly what blasts out of the gun. It's not just a bullet. You're also getting gas, flame, soot, and unburned powder.
And all that extra debris, gunshot residue, or GSR, is a forensic pathologist's absolute best friend. Think of it as an invisible ruler that measures exactly how far away the shooter was. If it's a contact wound, 0 centimeters, all those hot, expanding gases are forced directly under the skin. They violently expand against the bone, tearing the skin outward into a massive star-shaped stellate tear. Move back to close range, up to 15 centimeters, and the target gets hit by the whole shebang, flame burns, soot, and powder. At intermediate range, 15 to 60 centimeters, the flame and soot are too light to travel that far, but the heavier, unburnt powder still hits the skin, causing what we call tattooing. Finally, distant range, over 60 centimeters, no residue reaches the target at all, just a clean entry hole.
Okay, here is a high-yield memory trick that forensic students use to lock in this exact drop-off order. Fast soldiers travel. It tells you exactly what evidence disappears as the shooter backs away. Fast is for fire, or flame, which vanishes first around 15 centimeters. Soldiers is for smudge, the soot, which drops off next. And travel is for tattooing, the unburned powder, which travels the furthest but still drops off at 60 centimeters. Fast soldiers travel. Fire, smudge, tattooing. If you can remember that, you can read the invisible ruler at any crime scene.
But what about the wound itself? Well, an entry wound is highly specific. It's actually usually smaller than the bullet because human skin is elastic. To really visualize this, imagine a grease-covered man forcefully squeezing his way through a tight rubber doorway. As he pushes in, he forces the door to bend inward, right? That perfectly explains why entry wounds have inverted or inward-facing margins. As he aggressively squeezes through, the friction literally scrapes the surface of the door frame. That represents the abrasion collar, a scraped ring of skin around the hole.
And finally, the grease on his body wipes off onto the edges. That's the grease color left by the dirt and lead on the bullet.
This brings us to a brilliant cheat sheet for contrasting entry and exit wounds. It's absolutely crucial to tell them apart. As we just saw, entry wounds are generally smaller. The margins point inward, they have a grease collar, and most importantly, the abrasion collar is always present. That is your undeniable proof of entry. Gunshot residue might also be there, depending on the range. Now, exit wounds, totally different story. Because the bullet is pushing the skin out from the inside, the margins are everted, turned outward. They're usually larger and much more irregular. But the huge takeaway here, an exit wound has no abrasion collar, no grease collar, and zero gunshot residue. It's a completely different forensic signature.
Now, here's a common pitfall. People often think a bullet's damage is just about its size, but we have to look at the terrifying physics of what happens inside the body. The real destructive power relies heavily on kinetic energy. Check out this formula. Kinetic energy equals 1/2 mass times velocity squared. Notice that the velocity is squared. What does that mean? Well, if you double the weight of a bullet, you only double the energy. But if you double the speed, you quadruple the energy. That is exactly why high-velocity military rifles, like an M16, deliver such catastrophic kinetic energy compared to a standard handgun.
Let's break down the mechanism of that destruction. When a high-velocity bullet hits, it violently dumps all that squared kinetic energy into the body's water-rich tissues. This creates a massive outward shockwave called temporary cavitation. In a fraction of a millisecond, this cavity expands 10 to 15 times larger than the bullet itself. This explosive stretching instantly shreds blood vessels, nerves, and organs that the bullet literally never even touched. It's a vital medical concept because it shows why a bullet doesn't actually have to strike the heart directly to be fatal. The sheer concussive shockwave of temporary cavitation can cause unsurvivable internal trauma all on its own.
Which brings us to an incredible clinical correlation. When a victim of this kind of trauma hits the ER, you have a massive clash of priorities. The surgeons are following their golden rule. Treat the patient, not the bullet. They are there to stop catastrophic bleeding, not go digging for a piece of metal that isn't hitting a vital nerve. But while they are saving a life, they also have to preserve evidence. They can never cut clothing straight through the bullet hole, because that fabric holds the residue. If they do pull a bullet out, they can never use serrated steel forceps. The hard steel will gouge the soft lead and completely destroy the microscopic striation marks, the bullet's unique fingerprint. And finally, biological evidence has to go into breathable paper bags, not plastic, so it doesn't rot.
Okay, let's bring this all the way back to the ER tragedy we opened with. Remember our heavily scrubbed wound? To solve this, we have to contrast two key pieces of gunshot residue: soot, which causes smudging, and unburnt powder, which causes tattooing. Smudging is literally just smoke and cardon. It sits lightly on top of the skin and can be wiped or washed away super easily with alcohol. But unburnt powder, that is a completely different beast. These are hard physical granules of chemical propellant that hit the skin like tiny pieces of shrapnel. They don't just sit on the surface, they embed themselves deep, deep into the dermis layer. This ballistic tattooing is permanent, it is physically impossible to just wash away.
And boom, here is the ultimate payoff to our mystery. That well-meaning nurse scrubbed the wound with betadine, which wiped away the soot. The suspect, knowing a distant shot wouldn't have soot, confidently claimed a 5-meter self-defense distance. But the pathologist knew exactly what to look for. Using a magnifying lens on that scrubbed skin, they found distinct, unwashable red and brown stippling embedded right into the tissue around the hole. It was tattooing, and since the laws of physics dictate that tattooing only happens if the gun is fired from an intermediate range of under 60 centimeters, the scientific evidence absolutely shattered the 5-meter alibi. The undeniable, permanent nature of that microscopic ballistic tattoo proved the shooter was standing at point-blank range, and it resulted in a conviction for premeditated murder.
The body really does keep the score, doesn't it? It acts as this undeniable ledger of physical truth, if you just understand the science of how to read it. As we've seen today, even when evidence is seemingly scrubbed clean, physics and anatomy always leave a trail. So, I want to leave you with this thought. If a simple wash of a wound in a chaotic ER can nearly erase the truth of a brutal crime, what other invisible scientific stories are hidden on the human body just waiting for the right expert to read them? Thank you so much for joining me on this explainer, and remember to always keep questioning what you see.